All right, we're on number 2. This is another example of solving systems by substitution. So in this problem, I think as we decide which variable to isolate, unlike the last problem where we isolated x, I think this time isolating y will be easier, again, because we're looking for a variable that, if possible, if we can find one that only has a 1 coefficient, not a 6 or a 3 or an 18 where we would need to divide and maybe end up getting fractions. So I think let's solve for y in the first equation, which means we would start by adding 6x to both sides. So that means y equals 6x minus 8. Now we can substitute into the second equation, meaning I'm going to replace y with this new expression of 6x minus 8. So here's our second equation. Instead of negative 3y, I'm leaving some parentheses open, and I'm going to replace y with this new expression 6x minus 8. Okay, now when we distribute negative 3 times 6x, it's negative 18x. Negative 3 times negative 8 would be positive 24. And then we still have plus 18x equals 4. So now we have only x in this equation. So our goal is to solve for x. But as you might notice right now, if we try to combine like terms, the negative 18x and the positive 18x actually just cancel out altogether. So that's kind of weird. So we get this equation 24 equals 4. We can stop right there because we're done. 24 is not equal to 4. That is not true. So if we did the correct steps but ended up with an equation that's not true, what this means is this system is inconsistent and it has no solution. So I just drew a circle with a slash through it, which is one way to say there's no solution, or you can literally write no solution. So if your variables cancel out altogether, take a look at the equation that's left over. If it's true, for example, if we got 24 equals 24, or 0 equals 0, or 5 equals 5, that's a true statement. That would be the case of the two lines being the same line, and you would have infinitely many solutions. In this example, if we were to graph these two lines, they would both have a slope of 6, but they have different y-intercepts. So they're both going up 6 over 1, but they're never crossing. These would be parallel lines. They never intersect. There's no solution. We don't need to graph to know that for sure. The way we could tell is we could see that the variables completely canceled out. We were left with an equation that's not true. And so the problem is done and there's no solution.